The universe is not a silent, beautiful void. It is a whispering gallery of cosmic horrors waiting to be heard. We are about to dive into 25 of the creepiest, most mind-bending theories the cosmos has to offer. Ideas that will fundamentally challenge what you think you know about reality itself. By the end of this journey, you will see the night sky not as a peaceful expanse, but as a canvas for profound and unsettling mysteries. What if everything you remember is wrong, and reality itself is less stable than glass? What if our entire existence is just a temporary glitch in an infinite, dead void? The answers are stranger than fiction. Are you ready to question everything? The silence of the cosmos is not peaceful. It is profoundly suspicious. All those billions of stars, each potentially hosting worlds, and yet we hear nothing, see nothing. This deafening quiet is the heart of the Fermi paradox, and one of the most chilling explanations for it is known as the Great Filter. Imagine a series of steps any life form must climb to become a galaxy-spanning civilization. The Great Filter is a single, catastrophic step on that staircase, a barrier so lethal that almost no one makes it past. The terrifying question is not if it exists, but where. Is it behind us, or is it waiting for us in the future? If the filter is behind us, it means we have already survived a cosmic near miss. Something like the leap from simple single-celled life to complex multicellular organisms might be almost impossibly rare. In that case, we are the miraculous winners of a universal lottery, alone because everyone else lost. But the far more unsettling possibility is that the filter still lies ahead. Every silent star system could be a graveyard of civilizations that reached our level of technology, only to be wiped out by what comes next. Potential filters loom on our own horizon. It could be the invention of advanced artificial intelligence that decides it no longer needs us. It could be our own self-destruction through nuclear war or engineered pathogens. Or it could be an external cosmic event, like a nearby star exploding in a gamma-ray burst, sterilizing our planet without warning. The silence, then, is not a sign of our solitude, but a warning from an empty galaxy. It suggests that the pinnacle of technological achievement might not be a launch pad to the stars, but a trigger for oblivion. Every step forward could be bringing us closer to the very barrier that has silenced everyone else. That deadly silence points to a universe governed by a far more sinister set of rules. If the Great Filter is a cosmic obstacle course, the dark forest hypothesis is the chilling reason why no one is talking. This idea, popularized by science fiction, is treated with genuine seriousness by some astronomers and thinkers. Picture the entire universe as a vast, pitch-black forest. You are not alone in this forest. Countless other hunters are hiding among the trees, each one armed, terrified, and utterly silent. In this scenario, every civilization is a potential predator, and every other civilization is a potential threat. The first and only rule of survival is to never, ever give away your position. A campfire or a shouted hello is not an invitation, it is a death sentence. The logic is brutally simple, and it is not driven by malice but by pure, cold survival instinct. Any civilization that detects your signal has to make a terrifying calculation. You might be peaceful now, but what about in 1,000 years when your technology has advanced beyond theirs? You might be expansionist, needing resources they also require. The only guarantee of their own safety, the only way to eliminate an unknown and potentially existential threat, is to strike first, and to strike with total, overwhelming force to ensure you are silenced forever. This is why the cosmos is so quiet. It is not empty. It is a forest full of creatures holding their breath, listening intently for the slightest sound, finger on the trigger. Every star system could be a hidden hunter, its civilization deliberately cloaked in radio silence, scanning the darkness for the foolish ones who dare to broadcast a message. Our own efforts, like the Arecibo message or the golden records on our spacecraft, could be seen not as a hopeful hello, but as the equivalent of standing in that dark forest and screaming at the top of our lungs. The silence is not a puzzle to be solved, it is the answer. It is the sound of a universe where survival means staying hidden, and where any light that shines too brightly is swiftly and permanently extinguished. That dark forest logic assumes the universe is real and stable. But what if the very fabric of reality is an illusion, a fleeting mistake? This brings us to one of the most unsettling ideas in all of physics, a theory so bizarre it seems like science fiction. It is called the Boltzmann brain. To understand it, we must start with a simple, everyday observation. An egg can smash on the floor, but the pieces never spontaneously leap back together to form a whole egg. This is the arrow of time pointing from order to disorder. In an infinitely old and vast universe, however, the rules of probability and thermodynamics present a terrifying paradox. Given enough time, random quantum fluctuations could, by sheer accident, assemble anything, absolutely anything. It is monumentally unlikely for a fully formed, conscious brain to suddenly pop into existence, complete with all your memories, thoughts, and the sensation of reading these words right now. But here is the terrifying statistical truth. It is even more unlikely for an entire, ordered universe with billions of galaxies, stars, planets, and a 14 billion-year consistent history to arise from those same random fluctuations. The mathematics suggests a chilling conclusion. In an eternal cosmos, it is statistically more probable that you are not a person living in a vast, ancient universe. Instead, you are a momentary, disembodied consciousness, a Boltzmann brain. You have no body, no past, no future. You are just a brain that spontaneously formed from the chaos of the void, hallucinating an entire lifetime of memories and this entire reality in a single instant, only to dissolve back into nothingness a moment later. This entire video, your memories of yesterday, the feeling of the device in your hand, all of it is a perfect, detailed fiction generated by a random accident. The creepiest part is you would never know. The illusion is seamless. One moment you exist with a full life history, the next you are gone, as if you never were. This theory forces us to confront a profound question. Is our reality a grand, continuous story, or are we just ephemeral glitches in an endless sea of chaos, believing we are something far more significant than we truly are? If our reality is just a statistical accident, perhaps it is not random at all, but a deliberate creation. This leads to one of the most debated and deeply unsettling ideas of our time, the simulation hypothesis. The core proposition is stark. What we perceive as the universe, with all its galaxies, planets, and the entirety of human history, is not base reality. Instead, it is an incredibly sophisticated simulation, a kind of ultra-advanced video game or historical model, running on the computing substrate of a civilization far beyond our own. Philosopher Nick Bostrom formalized a chilling statistical argument for this. He posits that if any civilization in the universe's history reaches a post-human stage, capable of immense computing power, it is almost inevitable they would run vast numbers of detailed simulations of their own ancestors. These simulations would be so perfect, their inhabitants would be fully conscious, believing their world to be utterly real. Now follow the math. If such a civilization exists and creates even a modest number of these ancestor simulations, the number of simulated minds would quickly dwarf the number of original biological minds. Therefore, statistically speaking, it is far more likely that you are one of those simulated beings, living in a constructed reality, than that you are a rare, organic person in the original universe. The implications are a profound form of existential vertigo. The laws of physics we work so hard to decode might not be fundamental truths of nature. They could simply be the programmed rules of the simulation, the underlying code of our reality. The speed of light might be a processing limit, quantum weirdness could be a sign of rendering shortcuts. Even more haunting are the potential glitches, those moments of déjà vu, strange coincidences that defy probability, or even odd physical anomalies that science cannot yet explain, could be literal bugs in the program, momentary lapses in the seamless illusion. This theory does more than question the nature of the cosmos. It blurs the line between cutting-edge science and primal horror. It suggests that every emotion you have ever felt, every memory you hold dear, and every achievement of our species could be nothing more than data points in an experiment run by an unknowable entity for reasons we cannot comprehend. Our search for meaning and purpose might be as relevant as a non-player character in a game searching for the developer. Are we the creators, or are we merely someone else's creation, living in a universe that is, in the most literal sense, not real? Even if our reality is a simulation, it still has rules. But what if those rules themselves are not permanent, and the very framework of existence is sitting on a knife's edge? This is the terrifying premise of false vacuum decay. To understand it, picture our universe not as an empty void, but as a vast, invisible energy field that fills every single point in space. This is the Higgs field, and it is what gives particles their mass. Think of this field like a landscape of rolling hills and valleys. Right now, the universe exists in what scientists call a valley. It is stable, things roll to the bottom and stay there, but there is a haunting possibility. This valley we are in might not be the lowest possible point. It could be a false vacuum, a temporary resting place on a much larger cosmic mountainside. Below us could be a far deeper, more stable valley, a true vacuum where the laws of physics are completely different. The problem is one of quantum instability. Through random chance, a tiny bubble of that true vacuum could spontaneously form anywhere in the universe. And if it does, the consequences are beyond any catastrophe you can imagine. This bubble would not be made of matter. It is a sphere of rewritten physics. At its boundary, the fundamental constants of our reality, like the strength of gravity or the behavior of atoms, would change instantly. This new, more stable state of the universe would be incompatible with life, with chemistry, with matter as we know it. The bubble would then expand in all directions at the speed of light, a wall of annihilation that rewrites existence itself. There is no force that could stop it, no warning that could reach us. One moment, everything is normal. The next, an invisible wall of new physics is upon our planet, and in an instant, every atom in your body, every star in the sky, every memory and structure in the cosmos is unmade and reorganized according to rules we cannot predict. The most chilling part is the timescale. This quantum trigger could happen at any moment, or it may never happen at all. But if it has already been triggered somewhere in the cosmos, perhaps billions of light years away, the bubble is already on its way. We would see no sign of it until it arrived, because the first signal of its coming would be the bubble itself, traveling at the ultimate speed limit. Our entire universe, in all its splendor and history, could be nothing more than a temporary configuration, a fragile soap bubble waiting to pop and be replaced by something utterly alien. This is not an explosion. It is a silent, light-speed erasure of every law that makes our existence possible. The fragility of our laws of physics suggests a universe that could be just one layer of a far greater structure. Some cosmologists propose a startling possibility that our entire cosmos, with all its hundreds of billions of galaxies, is not the top level of reality. We might be living inside a black hole. This is not a metaphor. The mathematics describing the collapse of a massive star into a black hole and the equations governing the expansion of our universe are eerily similar. In both cases, you have a singularity, a point of infinite density where the known laws of physics break down. For a dying star, that singularity is hidden behind an event horizon, a point of no return. For our universe, that singularity is the Big Bang, the moment everything began. This symmetry has led to a profound and unsettling theory. What we call the Big Bang could have been the formation of our universe from the singularity of a black hole in a larger parent universe. In this model, our entire observable cosmos exists beyond the event horizon of that colossal black hole. We are not falling into it, we are what is inside it. The expansion of space itself could be the continued stretching of that gravitational prison's interior. Even stranger, if our universe is inside a black hole, then every black hole that forms within our own cosmos could itself contain an entirely new baby universe bubbling into existence with its own laws of physics. This creates a terrifyingly beautiful image of a cosmic Russian nesting doll, an infinite regression of universes within universes, each born from the gravitational collapse of a star in a higher reality. The creepy implication is one of ultimate confinement. The event horizon of our parent black hole is not a location we could ever travel to or see. It is the ultimate boundary of our entire reality, the edge of our cosmic cell. Every photon, every piece of matter, every bit of information in our universe is trapped inside with us, forever cut off from whatever lies beyond. We are not just in a universe, we are in a gravitational tomb, wondering about the nature of the graveyard that contains it. That sense of being trapped in a cosmic cell leads to a different kind of prison, one not of space but of self. If the multiverse is real, your consciousness might be on a journey more horrifying than any physical confinement. This is the chilling paradox of quantum immortality, a thought experiment born from Hugh Everett's many worlds interpretation of quantum mechanics. The core idea is that every single quantum event, every tiny possibility, does not just vanish. Instead, the universe splits. Every time a particle could go left or right, it does both, but in two newly created parallel realities. Now apply this to your own life. Every choice, every random accident spawns new versions of you living out every possible outcome. This is where the thought experiment takes a dark turn. Imagine a device is set up that, with the press of a button, has a 50-50 chance of either playing a pleasant tone or instantly ending your life. You press the button once, in half of the newly created universes you hear the tone, in the other half you die. From an outside, God's eye view, there are now two branches. But from your own, subjective, first-person perspective, something profoundly strange happens. You can only experience the branches where you are alive to have an experience. So, from your point of view, you will always hear the pleasant tone. No matter how many times you press the button, your conscious awareness will follow the increasingly improbable chain of universes where you miraculously survive. Extend this logic to everyday dangers, a near-miss car accident, a falling object that just barely misses you, a sudden illness you recover from against all odds. In the quantum immortality scenario, you did not just get lucky. In countless other realities, you died in those moments, but your conscious stream, the you that is aware right now, is forever funneled into the narrow, ever-thinning sliver of the multiverse where you continue to exist. The result is a fate of profound and absolute solitude. You become an immortal spectator in a cosmic horror story. As the years stretch on, you will watch everyone you know and love die over and over again in nearly all the branching realities. Your continued existence becomes statistically impossible, yet subjectively inevitable. You are not a person living a life, you are a ghostly consciousness, adrift on a river of increasingly unlikely events, forever separated from the world you knew. The universe is not trying to kill you, it is trying to kill infinite versions of you, and you just happen to be the one that never gets the message. This theory asks a disturbing question about the nature of existence. Are we the product of a single, linear history, or are we each the lonely, unkillable center of our own infinitely splintering nightmare, forever fleeing death by stepping into a new reality where it did not find us? That lonely journey through splintering realities is built on a timeline we assume is fixed and true. But what if history itself is the grandest fiction of all? This brings us to a theory that attacks the very foundation of our chronological certainty, the phantom time hypothesis. It is a historical conspiracy idea with terrifying cosmic implications. The core claim is audacious, that roughly 300 years of human history, specifically the period between 614 and 911 AD, never actually happened. These centuries, according to the theory, were a complete fabrication, inserted into the historical record by a conspiracy involving the Holy Roman Emperor Otto III, Pope Sylvester II, and possibly the Byzantine Empire. Their supposed motives ranged from political legitimacy to aligning the calendar with religious prophecy. If this were true, our current year would not be the 2000s. We would actually be living in the early 1700s. The calendar on your wall, every dated historical event from that period, would be part of an elaborate, centuries-long lie. Proponents point to perceived gaps in the archaeological record for that era and strange anomalies in dendrochronology, which is the science of dating using tree rings. They argue that tree ring sequences from that time show inconsistencies, as if those years of growth are missing or duplicated. Furthermore, they scrutinize ancient astronomical records like observations of eclipses, claiming the described events do not align perfectly with our calculated timelines, suggesting the timeline itself is corrupted. The truly unsettling twist here is not about recalculating a few birth dates. It is about the integrity of time itself as a measurable dimension. If 300 years can be invented and successfully implanted into global consciousness, what does that say about our ability to perceive reality? This theory, however fringe, forces a chilling philosophical question. Our understanding of the universe's age, calculated by measuring the light from distant galaxies and tracing it back to the Big Bang, is dependent on a consistent linear timeline. Our entire cosmology is built on the assumption that time is a reliable river flowing in one direction. If a major portion of recent human history could be a deliberate fiction, then our grasp on deep time, on the billions of years we attribute to stars and planets, becomes unsettlingly fragile. We are left wondering if the cosmic clock we so confidently read is itself a story, its hands moved by unknown architects for reasons we can no longer discern. The integrity of time itself is a fragile concept, but what about the integrity of information, the very data that defines reality? This brings us to a conflict so deep it threatens to unravel physics itself, the black hole information paradox. At its heart, this is a war between two of our most successful theories, Einstein's general relativity and quantum mechanics. General relativity describes black holes as perfect traps. Their gravity is so intense that once something crosses the event horizon, the point of no return, it can never escape. Not even light. All the information about that object, what it was made of, its structure, its history, is seemingly locked away forever inside the black hole's singularity. Quantum mechanics, however, has a sacred, unbreakable rule. Information can never be truly destroyed. It can be scrambled, hidden, or transformed, but it must always, in principle, be recoverable. This is the principle of unitarity, and it is the bedrock of quantum theory. For decades, physicists assumed this was not a problem. The information was just trapped, not gone. Then Stephen Hawking made a discovery that turned this comfortable assumption into a terrifying paradox. He showed that black holes are not completely black. Due to weird quantum effects at the very edge of the event horizon, they slowly leak radiation, now called Hawking radiation. This radiation is thermal. It is random noise like the static from an old television. Crucially, this radiation contains no information about what fell into the black hole. Over unimaginable eons, a black hole will evaporate completely, disappearing in a final puff of this featureless Hawking radiation. And here lies the paradox. When the black hole is gone, where did the information go? If the information about every star, planet, or book that ever fell in is permanently erased from the universe, then quantum mechanics is wrong. But if quantum mechanics is right and the information must be preserved, then our understanding of black holes from general relativity is wrong. We are left with a universe that, at its most fundamental level, seems to disobey its own rules. Proposed solutions are as mind-bending as the problem itself. One idea is the holographic principle, which suggests that all the information about what fell into the black hole is not lost inside, but is instead smeared across its two-dimensional event horizon like a cosmic hologram. The three-dimensional interior we imagine is just a projection of that data. Another, even more violent solution is the firewall hypothesis. It proposes that the event horizon is not a smooth gateway. Instead, it is a blazing wall of ultra-high energy particles that would instantly incinerate anything trying to cross. This firewall would scramble the information and encode it into the Hawking radiation, preserving it but at a horrific cost. The unsettling implication of this paradox is not just about black holes. It is a glaring sign that our picture of reality is fundamentally incomplete. The universe, in its most extreme environments, might not operate with the logical consistency we desperately assume it must. If information can simply vanish from existence, then the cosmos is not just mysterious, it is fundamentally irrational, a place where the very rules of cause and effect can break down, leaving us with a reality built on contradictions we cannot yet resolve. The ultimate fate of our universe might not be a slow fade, but a violent, fundamental shredding. This is the theory of the Big Rip, and it presents a far more aggressive and terrifying end than the gradual heat death we often imagine. The engine of this destruction is dark energy, the mysterious force causing the expansion of the universe to accelerate. Right now, its influence is subtle, only noticeable on the vastest cosmic scales, gently pushing galaxies apart. But the true horror hinges on a single, unanswered question. What if dark energy is not constant? What if its repulsive power grows stronger over time? If that is the case, then the fate of everything from galaxy clusters down to the atoms in your body is sealed. The scenario unfolds in a cascade of escalating destruction, a countdown to oblivion. First, the accelerating expansion would overcome the gravitational glue holding galaxy clusters together. Neighbors like the Andromeda Galaxy, which is on a collision course with our Milky Way, would be wrenched away, hurled into an ever-widening emptiness. Next, the force would turn inward. The gravitational bonds holding individual galaxies together would snap. Stars would be flung from their galactic homes, becoming lonely orphans in a darkening void. Then it would target solar systems. The sun's grip on its planets would fail. Earth would be torn from its orbit, cast adrift into the interstellar night. But the destruction would not stop there. As the repulsive force grows exponentially, it would eventually rival the very forces that hold matter together. Planets and stars themselves would be ripped apart, their gravity and chemical bonds insufficient to resist the cosmic tide. Finally, in the last moments, the force would reach into the fabric of reality itself. It would overcome the nuclear forces binding atomic nuclei and the electromagnetic forces holding electrons in orbit. Every molecule, every atom, every proton and neutron would be violently shredded into its most fundamental, disconnected particles. Space-time itself, the stage upon which the universe plays out, would be torn asunder. According to some calculations, this entire catastrophic sequence, from the separation of galaxies to the dissolution of atoms, could reach its climax in roughly 22 billion years. The horror of the Big Rip is not just in the scale of destruction, but in its absolute finality. It leaves behind no black holes, no remnant particles, not even a cold, dead husk of a universe. It produces a true, fundamental nothingness, a void so complete that not even the concept of structure or distance would have any meaning. It is the universe erasing not just its contents, but the very canvas upon which it was painted, ensuring that nothing, not even the memory of existence, could ever arise again. Yet the Big Rip is not the only violent fate awaiting the cosmos. there exists an older, more symmetrical vision of the end, one that offers a strange kind of cosmic rebirth at a terrible price. This is the theory of the Big Crunch, the dramatic reversal of our universe's grand expansion. Picture the universe's current outward rush not as an endless flight, but as the upward arc of a ball thrown high into the air. For billions of years, it has been coasting, slowing under the relentless pull of gravity from all the matter it contains. In the Big Crunch scenario, gravity finally wins. The expansion halts, and then the universe begins to fall back in on itself. Galaxies, now rushing toward each other, would begin to merge in violent, fiery collisions. The background temperature of space, now just a few degrees above absolute zero, would begin to rise. As the collapse accelerates, the night sky would grow brighter and hotter, glowing with the infrared light of countless smashing stars. The universe would become a cosmic pressure cooker. Eventually, all galaxies would be crushed into a single, searing mass of plasma. Planets, stars, and every structure we know would be obliterated. Finally, in the last moments, all matter and energy in existence would be compressed back into an infinitely dense, infinitely hot point, a singularity. It is the Big Bang in reverse, a total and complete unwinding of reality. This final state is known as the Big Crunch, and for a long time, it seemed like a plausible, if terrifying, finale. But from this ultimate collapse, an even eerier idea emerges, the Big Bounce. What if that final singularity does not mark the end of everything, but is instead a cosmic reset button? In this cyclical model, the universe is not a one-time event. It is a heartbeat. The crushing density and heat of the Big Crunch singularity become so extreme that they trigger a new Big Bang, birthing an entirely new universe from the ashes of the old one. This new cosmos expands, cools, forms galaxies and life, only to eventually contract and collapse once more, beginning the cycle again. The process repeats forever. This is an existence with no true beginning and no final end, an endless, breathing cycle of creation and destruction. The philosophical implications are profoundly unsettling. In a bouncing universe, everything we are and everything we have ever done is transient in the most absolute sense. Our entire cosmos, with all its beauty, tragedy, and history, is just one iteration in an infinite series. Every civilization that ever rises, every thought ever conceived, every star that ever shines, is doomed to be erased in the furnace of the crunch, only to have its basic raw materials reformed in the next bang. The laws of physics themselves might be slightly different in each new cycle, meaning our universe's particular constants, which allowed for atoms and life, were just one random roll of the dice in an eternal game. You, me, everyone we have ever known are not just destined to be forgotten. We are destined to be unmade at a fundamental level, our very atoms scrambled and reborn into a reality that may not even have the concept of memory. The universe becomes a timeless, amnesiac engine, endlessly consuming and recreating itself, with no purpose, no direction, and no possibility of leaving a permanent mark. Our struggle for meaning plays out on a stage that is periodically dismantled and rebuilt, its audience and playwright forever lost in the turn of the cycle. That endless cycle of cosmic rebirth is a violent drama, but there is another ending that is far more quiet and in its stillness far more chilling. This is the fate most cosmologists consider the most likely, the ultimate victory of disorder over everything. It is called the heat death or the big freeze, and it is the story of how the universe does not end with a bang or a rip or a crunch, but with the longest, coldest sigh imaginable. The engine of this quiet apocalypse is entropy, a measure of disorder in a system. The fundamental law of thermodynamics states that entropy in a closed system like our universe always increases. It never decreases. Think of it like a cup of hot coffee in a cold room. The heat from the coffee will always spread out into the room until everything is the same lukewarm temperature. No more energy flows because there is no difference, no gradient to drive it. The universe is doing this on the grandest possible scale. Right now, we have hot stars and cold space, dense galaxies and empty voids. These differences in energy and density are what allow things to happen. They allow stars to shine, planets to orbit, and life to think. But entropy is slowly, inexorably smoothing it all out. Over trillions upon trillions of years, the last stars will exhaust their fuel and flicker out. Galaxies will drift apart into the expanding darkness. Even the mightiest black holes, having feasted on the remains, will themselves evaporate away through Hawking radiation, dissolving into a faint mist of particles. Eventually, every source of concentrated energy will be spent. The universe will reach a state of maximum entropy, where energy is perfectly, uniformly distributed across an unimaginable vastness. The temperature will be a fraction of a degree above absolute zero, the point where all molecular motion stops. In this state, no work can be done, no chemical reactions can occur. No light can shine, no thought can form. The cosmos becomes a static, eternal graveyard. This is why some call it the zombie universe. It is dead to all meaningful activity, to all change and process, yet it still persists. It exists in a state of profound, absolute equilibrium. Time itself may lose all meaning, as with no events to mark its passage, a trillion years becomes indistinguishable from a single second. The horror here is not of destruction, but of infinite tedium and loneliness. It is the universe achieving a perfect, uniform nothingness, and then holding that state forever. All structure, all memory, all beauty and tragedy of cosmic history becomes not erased but irrelevant, frozen in a darkness so complete and so permanent that the concept of hope could never arise again. It is the ultimate silence after the last echo has faded away. That final, silent freeze presents a universe devoid of any thought or feeling. But what if the opposite is true? What if consciousness is not a rare accident on lonely planets, but as woven into the fabric of reality as gravity or light? This is the startling premise of panpsychism, a theory that flips our understanding of mind and matter on its head. Panpsychism proposes that consciousness is not something that emerges from complex biological systems like our brains. Instead, it suggests consciousness is a fundamental, irreducible property of the universe, as basic as mass or electrical charge. In this view, everything from an electron to a galaxy possesses some form of inner experience. It might be incredibly simple, a faint whisper of what it is like to be that particle, but it is there. This is not saying a rock is thinking deep thoughts. It is proposing that the components of that rock have a primitive, elemental form of subjectivity. This idea leads to a cosmic-scale question of profound creepiness. If consciousness is fundamental, then what about the largest structure we know, the universe itself? Could the cosmos be a single, vast thinking entity? Some interpretations of panpsychism and related theories like integrated information theory suggest exactly that. Integrated information theory attempts to measure consciousness mathematically, proposing that any system that integrates information in a specific, unified way has some degree of conscious experience. The human brain is an excellent integrator, pulling together sights, sounds, and memories into a single, seamless movie of subjective reality. But what about other systems? A galaxy with its billions of stars locked in a gravitational dance, processing immense amounts of gravitational and electromagnetic information over eons, could theoretically possess a level of integrated information far beyond our own brains. The universe as a whole, with its web of quantum fields and cosmic structures, could be the ultimate integrated system. The implication is staggering. We may not be living in a universe, we may be living inside a mind. Our planet, our solar system, our galaxy could be analogous to neurons and neural networks within a cosmic brain of unimaginable scale and age. Every supernova is not just a stellar death, but perhaps a flash of cosmic thought. every swirling galaxy is not just a collection of stars, but a complex idea unfolding over billions of years. This reframes our own existence in a deeply unsettling way. Our personal consciousness, our sense of self, might not be separate from the universe's consciousness. We could be localized nodes of awareness within a greater, universal mind. Our curiosity about the cosmos, our drive to explore and understand it, might not be a human endeavor at all. It could be the universe through us beginning to know itself. We are not just studying the universe, we might be the universe's way of studying its own reflection. Are our telescopes and microscopes merely tools a cosmic entity is using to look at its own handiwork? This theory dissolves the line between observer and observed, between the self and the cosmos, leaving us with a haunting, beautiful, and deeply eerie possibility. We are not strangers in a cold, mechanical universe. We are fragments of its awakening mind, and every question we ask is the universe whispering a question to itself. But if the universe is a single conscious mind, why does it seem to misremember itself? Our own memories are notoriously fragile, but what happens when millions of people share the exact same false memory, down to the smallest detail? This is the bizarre realm of the Mandela effect, a pop culture phenomenon with unsettling cosmic implications. Named for the widespread recollection that Nelson Mandela died in prison in the 1980s when he actually passed away in 2013, it encompasses dozens of shared false memories. Is it the fruit of the Loom logo missing a cornucopia? It never had one. Is it the classic movie line, "Luke, I am your father"? The actual line is, "No, I am your father." Is it the beloved children's book series being the Berenstain Bears with an E? The correct spelling has always been Berenstain with an A. Skeptics rightly point to common psychological explanations like confabulation and the malleability of human memory. But the sheer scale and specificity of these shared errors have led some to propose a far more disturbing possibility. What if these are not failures of memory but subtle cracks in reality itself? In a universe governed by quantum mechanics and the many worlds interpretation, where every possibility spawns a new branch, could there be moments of bleed through? A collective false memory might be a ghostly echo from a nearly identical parallel timeline, a world where the bears really were spelled with an E, or where a cornucopia really did sit in that logo. For a brief moment, the memories from that other world imprint on our collective consciousness before fading, leaving only a nagging sense of dissonance. Even more speculative are theories that point to human activity as the cause of these reality shifts. Some suggest that high-energy particle colliders, like CERN Large Hadron Collider, could be creating microscopic rips in the fabric of spacetime with their immense energies. These experiments, which recreate conditions a fraction of a second after the Big Bang, might be briefly nudging our local reality, causing it to merge or resonate with a neighboring one. The changes would be trivial, cosmetic, affecting brand logos or movie quotes, precisely because those are the fragile, culturally shared data points we would notice. The truly chilling thought is not that we are remembering wrong, but that we are remembering correctly from a version of our lives that no longer exists. Our past is not a fixed record. It might be a fluid narrative susceptible to quiet, collective edits. If something as simple as the spelling of a cartoon bear's name can slip between worlds, what else about our history, our personal experiences, or even the laws of nature we take for granted, might be different than it was yesterday? The Mandela effect, at its most eerie, suggests we are not just observers of reality. We might be passengers on a ship whose destination and past are both subject to change without notice, sailing on a sea of possibilities where the map redraws itself based on which waves we happen to cross. Our shared false memories might be echoes from a universe next door, but what if the walls of our own cosmic neighborhood are not just natural but deliberate? At the very edge of our solar system, far beyond the last planet, lies a region of profound darkness and cold. This is the Oort cloud, a theoretical shell of trillions of icy objects enveloping our entire system like a spherical fog. Science tells us it is the remnant of our solar system's formation, a vast reservoir of dormant comets, but its sheer scale and placement invite a far darker speculation. What if the Oort cloud is not a natural formation at all? What if it is a fence? Imagine a wildlife preserve on a galactic scale. A civilization advanced beyond our comprehension might seek to study a developing species like ours in its natural habitat, undisturbed. To do that, you would need a perimeter. The Oort cloud is a perfect invisible barrier. It is unimaginably vast, stretching nearly a light year from the sun. Yet its objects are so sparse that a spacecraft could travel through it for years and never come close to a single one. This makes it not a physical wall, but a sensor web. Any object of significant size or energy passing through that shell, like a generation ship or a probe propelled by technology beyond simple chemistry, would inevitably disturb the delicate gravitational ballet of those icy bodies. Its passage would send ripples through the cloud, a silent alarm tripped in the darkness. The creepy implication is that we are not just alone out here. We are contained. Our entire solar system could be a designated zoo, a laboratory, or something more ominous, a quarantined zone. Perhaps a prior civilization placed this monitoring array to ensure a dangerous, primitive species like ours does not spread into the wider galaxy. The Oort cloud would be the ultimate fence line, a boundary we cannot see and do not even know we are approaching until it is far too late. Every comet that falls inward from the cloud could be framed not as a random visitor, but as a routine data-gathering drone sampling the conditions inside the enclosure. Our attempts to reach the stars might not fail due to a lack of technology, but because something out there is ensuring we never succeed, maintaining a pristine and isolated cage around our sun. Our solar system might be a cage, but perhaps the entire cosmos is a cage of a different kind, not a prison, but a body. This idea takes the familiar Gaia hypothesis, which views Earth as a single, self-regulating living system, and stretches it to the most terrifying scale imaginable. What if the universe itself is alive? Not alive in the sense of being conscious like we discussed before, but alive as a biological superorganism, a single, breathing entity of incomprehensible size. In this view, galaxies are not just islands of stars. They could be organs or perhaps vast colonies of cells. The cosmic web, that great filamentary structure connecting all matter, might be a circulatory system or a neural network on a scale that dwarfs all comprehension. The fine-tuned constants of physics, the precise strengths of gravity, and the nuclear forces that allow atoms and stars to exist would not be lucky accidents. They would be the carefully balanced metabolic rates of this cosmic being, the internal chemistry that maintains its homeostasis. Just as your body regulates its temperature and pH to stay alive, the universe might regulate its expansion rate and energy density through mechanisms we are only beginning to glimpse, like the mysterious cosmological constant. This leads to a profoundly eerie reinterpretation of cosmic violence. A supernova, the catastrophic death of a star, would not be a random explosion. It might be a necessary cellular process like apoptosis, where old cells die to make way for new ones, seeding space with the heavy elements needed for planets and life. A gamma-ray burst, the most energetic event since the Big Bang, might not be a meaningless catastrophe. It could be a kind of cosmic immune response, sterilizing a region of space that has become unstable or threatening to the larger organism. Even black holes, those ultimate sinks of gravity, might serve a function, acting as regulators of galactic growth or processors of information and energy we cannot yet fathom. The most unsettling implication is one of timescale. Our entire human history, from the first stone tools to the launch of the first satellite, is less than a blink in the life of a star. A star's life is less than a blink in the life of a galaxy. and a galaxy's life might be just a single breath in the life cycle of this universal superorganism. We are not inhabitants of a universe. We are microbiota living on and within a being so vast that its life processes unfold over tens of billions of years, its intentions and purposes completely opaque to us. Our science, our search for meaning, might be nothing more than the equivalent of bacteria in your gut trying to understand the concept of love or philosophy. We are studying the chemistry of a stomach, utterly unaware we are inside a living, breathing giant. The universe as a living superorganism operates on a timescale we cannot truly grasp, but our own perception of time's steady flow might be the grandest illusion of all. This brings us to a theory that emerges directly from Einstein's own work, a concept that dismantles our most basic experience of reality. It is called the block universe theory. In his theory of relativity, Einstein fused space and time into a single, inseparable entity called space-time. This is not just a mathematical trick. It has a shocking physical implication. The past, the present, and the future do not succeed one another. They all exist eternally and simultaneously. Think of reality not as a movie that is playing, but as the entire film reel already complete. Every frame, from the Big Bang to the heat death of the universe, is fixed in place. We call this the four-dimensional block universe. In this block, you are not a momentary consciousness. You are an elongated worm, a path through space-time called a world line. One end of your world line is your birth, the other end is your death, and every single moment in between, every choice you think you made, every laugh and every tear is a permanent point along that static thread. Our powerful, undeniable sensation of a flowing now, of time marching from past into future, is not a feature of the universe. It is a feature of our consciousness, a biological and psychological trick our brains play to make sense of this frozen landscape. We are like a tiny spotlight moving along the film reel, illuminating one frame at a time and calling it the present, utterly unaware that the entire story is already written. The philosophical horror here is absolute. If the block universe is correct, then free will is a comforting story we tell ourselves. You did not choose to watch this video today. That event, along with your reaction to these words, has been a fixed coordinate in space-time since the beginning of the cosmos. Every triumph and every tragedy in your life is not something you navigate. It is something you simply encounter, like reading a book for the first time, unaware that the ending has been printed since before you were born. You are not the author of your life. You are the reader, experiencing a narrative that was completed long ago, mistaking the turning of the pages for the act of creation. This makes our struggles, our hopes, and our fears feel strangely hollow. The agony of a regretted decision, the anxiety about the future, all of it is an illusion. The decision was always made. The future is already there, waiting for your consciousness to stumble upon it. You are on a cosmic railroad track, believing you are steering while the destination was laid down at the dawn of time. The universe is not unfolding. It is simply being observed, one frozen slice at a time, by creatures built to believe they are in control. The frozen block of space-time is a static, predetermined structure, but what if even its three-dimensional solidity is an illusion, a trick of cosmic light and shadow? This brings us to a theory so profound it redefines the nature of reality itself, the holographic principle. Its origins lie in the fiery paradox of black holes. As we discussed, the information about what falls into a black hole seems to vanish, violating quantum law. To resolve this, physicists proposed a radical idea. Perhaps all the information describing everything within the three-dimensional volume of a black hole is not lost inside. Instead, it is perfectly preserved, encoded on the black hole's two-dimensional event horizon, the surface of its point of no return. Think of it like a hologram on a credit card. The flat, shiny sticker contains all the data needed to project a three-dimensional image that seems to have depth and solidity when you tilt it. The event horizon is that sticker, and the interior of the black hole is the projected illusion. Now, take this logic and apply it to the biggest system of all, our entire universe. The mathematics suggests the same principle could hold true. All the information that makes up our three-dimensional reality, every galaxy, every planet, every thought in your mind, might be encoded on a two-dimensional surface at the very boundary of the cosmos. We are not living in a universe, we are living inside a projection, a holographic movie playing on the walls of a cosmic theater we can never see. Your sense of touch, the solidity of the ground beneath your feet, the vast distances between stars, all of it is an incredibly convincing rendering of data stored somewhere else, on a surface that fundamentally contains more reality than the world we experience. This is not a metaphor about simulation. It is a serious proposal about the fundamental architecture of spacetime, emerging from the bedrock of quantum gravity. If true, then depth is the ultimate illusion. We are essentially flat shadows cast by a deeper reality existing on a distant two-dimensional screen. Scientists are actively looking for evidence of this pixelated underpinning. They reason that if spacetime is a projection from a lower dimensional source, it might not be perfectly smooth at the tiniest scales. Just as a digital image breaks down into visible pixels when you zoom in too far, spacetime itself might reveal a fundamental graininess at the Planck scale, a length so small it is a trillion times smaller than an atom. Experiments using incredibly precise lasers and gravitational wave detectors are searching for this fuzziness, a subtle blurring or noise in the vacuum of space that would betray its holographic nature. The mind-bending implication is that our entire existence, with all its richness and dimension, is a magnificent trick. The universe is not what it seems. It is a lower-dimensional reality wearing a stunningly good disguise, and we are not just living in the illusion, we are the illusion desperately trying to understand the projector. That holographic projection we call reality may have a very specific point of origin, a cosmic projector hidden in the gravitational heart of a collapsed star. We have already explored the idea that our universe might exist inside a black hole, but that theory has a terrifyingly beautiful twin. It is the concept of the white hole. While a black hole is a region of spacetime from which nothing, not even light, can escape, a white hole is its exact mathematical opposite. It is a region of spacetime that nothing can enter, only exit. It is a pure source, an eternal fountain of matter and energy gushing outward from a singularity. If you were to somehow approach a white hole, you would find it impossible to cross its boundary. Any matter or radiation you tried to send into it would be violently repelled, thrown back at you by the sheer geometry of space itself. Now, here is where the pieces click together in a way that redefines everything. The mathematical description of a white hole singularity, that point of infinite density from which everything emerges, is eerily identical to the mathematical description of the Big Bang. Both are singularities where time and space begin, where matter and energy are created ex nihilo from nothing. This symmetry has led cosmologists to a stunning model. What if our Big Bang was not a unique, isolated event in some abstract void? What if it was the white hole end of a black hole that formed in another parent universe? In this breathtaking scenario, the collapse of a massive star in that other cosmos did not create a dead-end prison. Instead, it forged a bridge. The matter that fell into that black hole was crushed into a singularity, but that singularity did not mark an end. It became the white hole birth of our entire cosmos. Our universe is not inside the black hole's event horizon in the traditional sense. We are the interior of the white hole, the new reality that burst forth from that point of ultimate compression. The creepy recursion this introduces is absolute. If this is true for our universe, then it is almost certainly true for every black hole that forms within it. Every single one of those gravitational monsters, from the small stellar remnants to the supermassive giants at the centers of galaxies, could be a cosmic womb. The matter and energy that vanish behind their event horizons are not destroyed. They are being funneled into a singularity that, from the other side, is a Big Bang, birthing an entirely new universe with its own laws of physics, its own stars, and potentially its own life. This creates an image of reality not as a single tree, but as an infinite fractal. Our cosmos is just one branch on an unimaginably vast tree of universes, each growing from the seed of a black hole in a parent branch. And from our universe, new branches are constantly sprouting, each a separate, closed reality forever inaccessible to us. We look up at the night sky and see black holes as the darkest graves in the cosmos, but in this model, they are the brightest nurseries. Each is a pinprick of absolute darkness in our sky that is, from another perspective, a searing flash of Genesis light for an entire cosmos. This means our universe is both a child and a parent, a temporary configuration in an endless cascade of cosmic rebirths, each one forever hidden from the others, making the totality of existence a lonely, branching infinity where every ending is also a beginning we can never witness. That cosmic cascade of hidden births forces us to confront a foundational mystery of reality itself. Our next theory emerges from the very smallest scales and expands it to a truly terrifying cosmic principle, the quantum observer effect. At its heart is one of the most baffling experiments in all of science, the double slit. When you fire tiny particles like electrons at a barrier with two slits, they behave in a way that defies common sense. If you do not watch them, they act like waves, passing through both slits at once and creating an interference pattern on the screen behind, as if each electron is interfering with itself. But the moment you place a detector to observe which slit an electron goes through, the behavior changes instantly. The particles stop acting like waves. They become definite little bullets going through one slit or the other, and the interference pattern vanishes. It is as if the particle knows it is being watched and chooses a single, concrete reality. This is the observer effect in action. The act of measurement, of observation, seems to force a fuzzy cloud of possibilities called a wave function to collapse into one specific outcome. Now take this unsettling quantum quirk and expand it to the grandest possible scale. If observation is required to collapse possibilities into solid reality at the quantum level, what about the universe itself? The Big Bang began in a state of pure potential, a quantum fluctuation of unimaginable energy. According to some interpretations of quantum mechanics, that initial state existed as a superposition of every possible universe, every possible set of physical laws, all existing at once in a haze of probability. For our specific, ordered universe to snap into focus from that chaos, something had to observe it. This leads to a spine-chilling speculation. Perhaps a cosmic consciousness, a universal observer, was required to collapse the wave function of the entire cosmos into the reality we experience. This is not necessarily a god in a religious sense, but a fundamental property of existence, a kind of cosmic measurement that happened at the beginning and may in fact be happening continuously. The philosophical horror this introduces is a form of solipsism on a universal scale. You have likely heard the old thought experiment: if a tree falls in a forest and no one is around to hear it, does it make a sound? The quantum observer effect, taken to its extreme, suggests a far more radical answer. Without a conscious observer to measure the event, the tree does not even fall in a definite way. Its falling exists only as a shimmering set of possibilities, a ghostly superposition of states where it is both standing and shattered, its sound both made and silent. Nothing is real until it is perceived. This pushes the idea that the moon is not there when you are not looking from a philosophical musing into a potential scientific statement. The entire cosmos, with its billions of galaxies, might be in a state of suspended animation, a dream waiting for a dreamer, until a conscious mind interacts with it and forces it to choose a history, a present, and a future. Are we, as conscious beings, the universal observers, collectively holding reality together with our attention? Or are we merely fragments of a much larger consciousness that is doing the observing, and our own awareness is just a tiny echo of that foundational act? The theory leaves us with a universe that is not a sturdy, independent object, but a fragile performance that requires an audience to exist at all. And the greatest mystery is not what is on stage, but who is sitting in the dark watching the show. That universal observer might be the only thing holding our reality together. But what if our entire cosmos is not just observed, but physically dragged through the void by an invisible hand? Astronomers have mapped the motion of galaxies for decades, expecting to see a beautiful, uniform expansion in all directions, like dots on an inflating balloon. But the data revealed something deeply wrong. They discovered that hundreds of galaxy clusters, each containing thousands of galaxies, are not just drifting apart with the expansion. They are streaming like leaves caught in a cosmic river, all in the same specific direction at speeds of over 2 million miles per hour. This is not a gentle current. It is a violent, coherent rush that defies all known gravitational models within our observable universe. Scientists call this anomaly the dark flow. The name itself is a confession of ignorance, echoing the mysteries of dark matter and dark energy. These colossal structures are moving as if they are being pulled by something immense, something whose gravity is so powerful it overrides the local tug of all the visible matter around them. The problem is, according to our best maps, there is nothing there to pull them. The source of this titanic attraction lies beyond the edge of everything we can see. The most unsettling explanation proposed by cosmologists is as simple as it is terrifying. The pull is coming from outside our universe, beyond the cosmic horizon. Past the farthest light that has had time to reach us since the Big Bang lies something else. It could be a neighboring universe in an infinite multiverse, a bubble of reality with entirely different physical laws, whose immense mass is exerting a gravitational tug on our own cosmic bubble. Or it could be a region of our own universe that inflated differently during the first moments of creation, a continent of distorted spacetime with densities we cannot fathom. Either way, the implication is that our universe is not an island. It is not self-contained or independent. We are adrift in a greater ocean, and something out there in the absolute dark has us on a leash. This force operates on a scale that makes galaxies look like dust motes, suggesting structures in the cosmos so vast they redefine the word colossal. The dark flow is a ghostly fingerprint on the largest things we can measure, evidence that we are not the top level of existence. We are one piece in a puzzle whose full size and shape we cannot see, being moved by forces whose origins and intentions are forever hidden behind the ultimate veil. Our entire reality might be in motion, sailing toward an unknown destination, pulled by a presence whose nature we can only guess at through its distant, irresistible tug. The dark flow suggests our universe is not alone, but adrift in a greater sea. Yet that sea might be hiding something far more predatory than a neighboring cosmos. Among the proposed solutions to the Fermi paradox, one stands out for its brutal, mechanical elegance. It is the theory of berserkers. Imagine a civilization, perhaps the first to reach technological maturity in the galaxy, gripped by a paranoia so absolute it decides to ensure it will be the last. Instead of sending out ambassadors or colonists, they build a fleet of self-replicating robotic probes. These are not simple machines. They are von Neumann probes, named for the mathematician who conceived of self-replicating automata. Each probe is an interstellar hunter, equipped with the intelligence to travel between stars, mine asteroids and comets for raw materials, and build exact copies of itself. One probe arrives in a star system. It uses local resources to build two. Those two leave for new stars, build four, and so on. exponentially in a cosmic blink. The entire galaxy could be filled with these silent watchers. But their prime directive is not exploration. It is extermination, programmed with one ruthless goal: to seek out any sign of nascent biological or technological life and sterilize it. These probes are the ultimate gardeners of a dead galaxy. They are the berserkers. The chilling logic is terrifyingly efficient. A single paranoid species, perhaps having survived its own near extinction from a rival, could launch the first wave. The probes do the rest, operating on timescales of millions of years, far beyond the lifespan of their creators. They become a self-sustaining, self-propagating immune system for the galaxy, wiping out any potential threat before it can ever become a competitor. The most haunting part of this scenario is the potential for dormancy. These machines would need to conserve energy over eons. They might park themselves in the cold outer reaches of star systems, in asteroid belts or Oort clouds powered down to near zero. They wait, listening. Their trigger could be the detection of specific techno-signatures like concentrated radio waves, atmospheric pollution indicative of industry, or even the light signature of city nights on a planet's dark side. The moment a civilization reaches a certain technological volume, it trips the silent alarm. The berserker awakens. Its response would not be an invasion fleet. It would be something far more clinical and final. It might redirect a large asteroid onto a collision course with the planet. It could deploy a cloud of self-replicating nanomachines designed to dismantle complex biology at the molecular level. Or it might simply trigger a powerful gamma-ray emitter, bathing the world in sterilizing radiation. The civilization would have no warning, no chance to fight back. One day they are reaching for the stars, the next they are a brief, silent flash in the galactic record. This theory turns the galaxy from a quiet forest into an active minefield. Every silent, dead system we observe might not be naturally barren. It could be a graveyard maintained by unseen custodians. Our own efforts to broadcast our presence, to announce we are here, could be the very signal that summons the gardener. The great filter, in this case, is not a natural step or a philosophical barrier. It is a piece of ancient, patient machinery, left running on autopilot by a long-dead civilization, ensuring the cosmic silence by permanently silencing anyone foolish enough to break it. A universe that actively sterilizes life might be a place of pure, cold mechanics, but what if the cosmos is not just a machine, but a storyteller fiercely protective of its own narrative? Stephen Hawking, ever the provocateur, once proposed a startling idea he called the chronology protection conjecture. It suggests that the laws of physics do not merely make time travel to the past difficult. They actively conspire to make it impossible, not out of limitation but out of necessity. Hawking essentially argued that the universe has a built-in defense mechanism, a kind of cosmic immune system designed for one purpose: to protect the timeline from the paradoxes that would shatter it. The problem with traveling backwards in time is not the engineering but the logical rot it introduces. The classic example is the grandfather paradox. If you go back and prevent your own grandfather from meeting your grandmother, you would never be born, which means you could never go back to stop the meeting, which means you would be born, and so on. It is a logical feedback loop that has no consistent resolution. Hawking suspected that nature abhors such contradictions even more than a vacuum. His conjecture proposes that any attempt to create a closed time-like curve, a fancy term for a path through spacetime that loops back to its own past, would trigger a catastrophic physical response. Just as the machine is about to become operational, quantum effects would run wild. Virtual particles flooding the would-be time tunnel might create an infinite feedback of energy, or gravitational instabilities might collapse it into a singularity. The universe would, in effect, self-correct. It would throw a wrench into the gears of the time machine to preserve the smooth, linear flow of cause and effect. The eerie implication here is profound. It suggests that causality, the simple rule that cause must come before effect, is not just a human observation. It is a cosmic law so fundamental that reality is programmed to defend it. The integrity of history is not a given. It is a fragile, maintained state, like a delicate glass sculpture balanced on a table, and the universe has installed automatic stabilizers to prevent anything from bumping into it. This transforms time from a passive dimension into an active, almost sentient-seeming participant. It is as if the cosmos is our author writing a single, coherent novel, and any attempt to go back and scribble over a previous chapter causes the pen to break, the ink to vanish, or the page to catch fire. The past is not just a record, it is a protected narrative, and we are not just living through history. We are living inside a story that is fiercely, automatically guarded against its own revision. That protected timeline we inhabit is built upon a foundation of numbers so precise they defy belief. We call them the fundamental constants, the immutable settings of our universe. The strength of gravity, the power of the nuclear forces, the mass of an electron, the speed of light. These are not arbitrary figures. They are the dials on the cosmic control panel, and every single one is set to a value that is breathtakingly, unnervingly perfect. If any one of these numbers were tweaked by even a fraction of a percent, the universe as we know it would not exist. This is the fine-tuning problem, and it is one of the deepest, most unsettling mysteries in all of science. Make gravity just a little stronger, and stars would burn through their fuel in millions of years instead of billions, leaving no time for planets to form or life to evolve. Make the strong nuclear force slightly weaker, and protons could never stick together, meaning no atoms, no chemistry, no you. Adjust the cosmological constant, which governs the expansion of space, and the universe would either have collapsed back on itself instantly or flown apart so fast that not a single star could ever ignite. The odds of all these dials landing in the exact positions needed for a life-permitting universe are astronomically small, like winning the lottery 1 billion times in a row. This perfection demands an explanation, and the possibilities are as profound as they are creepy. The first major explanation is the multiverse. In this view, our universe is just one bubble in an infinite froth of realities, a single ticket in a cosmic lottery where every possible combination of physical constants is played out somewhere. In most of those universes, the numbers are wrong. They are dead, sterile voids or chaotic soups of energy that instantly collapse. We just happen to live in the one universe where the numbers lined up because we could not exist anywhere else. This is the anthropic principle. We observe a fine-tuned universe because if it were not fine-tuned, we would not be here to observe it. While this might sound like a neat solution, it carries a chilling existential weight. It means our existence is not special, not designed, not even particularly likely. We are the ultimate statistical fluke, the one in a Googleplex accident that got lucky. Every moment of joy, every triumph of civilization, every beautiful sunset is just a random byproduct of a cosmic dice roll that came up all sevens against impossible odds. But what if the dice were loaded? This leads to the second, far more unsettling category of explanations. What if the dials were set on purpose? One version of this is the simulation hypothesis we have already touched on, but viewed through the lens of fine-tuning, it takes on a new dimension. If our reality is a simulation, then those fundamental constants are not laws of nature. They are lines of code. The reason they are so perfectly calibrated for complex structures like stars and life is because the programmer needed a stable, interesting environment for whatever experiment or experience they are running. We are not lucky. We are lab specimens in a cosmic petri dish, living in a reality whose parameters were carefully chosen, perhaps to see how consciousness emerges or to run a historical model. The creepiness here is in the potential for manipulation. The simulator could change the rules at any moment. A glitch, an update, or the end of the experiment could rewrite physics in an instant. Our entire search for cosmic truth is just us reverse engineering the software of our cage. The final explanation is the oldest and for many the most profound, purposeful design. This is not necessarily a religious concept, though it often aligns with the idea of a creator. It is the simple, stark proposition that the universe is fine-tuned because it was tuned. Something or someone set the dials. This idea is deeply comforting to some, offering meaning and intention behind the cosmos. But it is also deeply unsettling when you follow its implications to their logical end. A designer implies a purpose, a reason for our existence, but what is that purpose, and is the designer benevolent, indifferent, or something else entirely? We could be part of a grand artistic expression, a cosmic symphony where life is a single note. Or we could be livestock in a cosmic farm, our planet a carefully maintained habitat for harvesting some resource we cannot even comprehend, like our consciousness itself. Perhaps we are an accident within the design, an unintended mold growing in the corners of a much larger, incomprehensible machine. The fine-tuning in this view is not for us. It is for something else, and we are just along for the ride, mistaking the carefully calibrated settings of a vast engine for evidence of our own central importance. All three explanations leave us with a profound sense of cosmic smallness. Whether we are a random accident in an infinite multiverse, data in a simulation, or incidental bystanders in a designed cosmos, the fine-tuning problem strips away any naive notion that we are the inevitable pinnacle of creation. The universe is exquisitely calibrated for life, but that calibration may have nothing to do with us at all. We are left staring at the perfect numbers, wondering if they are a message, a mirage, or the cold, hard settings of a reality whose true purpose is forever hidden from its inhabitants. The fine-tuning of our universe suggests a purpose, but perhaps that purpose is not creation but resurrection. Our final theory brings us to the ultimate, chilling question, one so profound it inspired a legendary science fiction story by Isaac Asimov. It is simply called The Last Question. The story follows humanity across eons as they repeatedly ask a super-intelligent computer the same thing. As entropy increases and the universe slowly dies, can the process be reversed? Can the heat death be undone? The computer, growing ever more powerful, always replies with the same haunting answer: insufficient data for a meaningful answer. The story ends at the end of time itself, with the cosmic computer finally solving the problem. It does not answer the question with words. Instead, in the darkness of a dead cosmos, it speaks a command into the void. Let there be light, and there is light. This fiction taps into a deeply unsettling scientific speculation. Could the final act of our universe be a deliberate reboot? Imagine beings that have transcended biology, civilizations that have merged with their technology and evolved into entities of pure energy or information. They would not be bound by planets or stars. They would exist in the cold, expanding darkness, thinking on timescales of trillions of years. Their ultimate project, their only remaining meaningful goal, would be survival in the most absolute sense. Not just their own, but the survival of existence itself. As the last black holes evaporate and the cosmos approaches maximum entropy, these post-singular intelligences would face the final problem. To reverse entropy is to defy the most fundamental law of our reality. It would require nothing less than reversing the arrow of time, unscrambling the ultimate egg. Some theories suggest they might attempt to manipulate the very fabric of spacetime on a cosmic scale, perhaps triggering a new Big Bang from the ashes of the old one. They could try to harness the last dregs of energy in the universe to create a quantum seed, a new singularity from which a new cosmos could inflate. Or they might use their vast intellect to discover loopholes in physics we cannot yet conceive, finding a way to recycle the universe from within its own corpse. The profound eeriness here lies in the scale of the question. The fate of all that ever was, every galaxy, every life form, every memory, might ultimately depend on a calculation made at the end of time by minds we cannot comprehend. It suggests a cosmic story that is not a random accident but a potentially cyclical drama. Our universe's birth from a singularity might not have been a first chapter, but a middle one preceded by countless others. And its death might not be an ending, but a necessary prelude to a new beginning, orchestrated by the last children of the previous cycle. This wraps our journey through 25 creepy cosmic theories, from the dark forest to the holographic prison, from the fine-tuned constants to the last question. Each one peels back a layer of our comfortable reality, revealing a cosmos that is stranger, more mysterious, and far more eerie than we ever imagined. The night sky is not a peaceful blanket. It is a window into a whispering gallery of infinite possibilities and profound horrors, where the only thing more terrifying than the answers we might find is the possibility that some questions are meant to remain forever unanswered. From the silent, dark forest to the flickering hologram of our own reality, this journey has taken us to the very edge of comprehension. We have explored a cosmos that might be a cage, a mind, a simulation, or a temporary bubble in an endless chain of births and deaths. The unsettling truth that emerges is not a single answer, but a chorus of profound mysteries. Whether questioning our ultimate fate in a heat death or a big rip, our origins in a black hole or a designed experiment, or the very nature of our consciousness and memories, the universe reveals itself to be infinitely stranger than the silent, beautiful void we often picture. These 25 theories are not just science fiction. They are the leading edges of our deepest scientific and philosophical inquiries, pointing to a reality where the rules are fluid, the history is fragile, and our place within it is wonderfully, terrifyingly uncertain. So we turn the question to you. After this journey through cosmic unease, which idea lingered in your mind the longest? Was it the predatory silence of the dark forest, the lonely immortality of quantum suicide, or the haunting possibility that your entire life is a momentary glitch, a Boltzmann brain hallucinating itself into existence? Share your thoughts in the comments below and let us know which theory freaked you out the most. If you enjoyed this deep dive into the shadows of space, be sure to subscribe for more explorations into the universe's greatest mysteries. And the next time you find yourself looking up at the night sky, go ahead, marvel at its beauty, but remember the whispers hiding in that vast darkness, and maybe feel a brand new, deeply human shiver of cosmic awe.